right. So for vector cross product, what a vector cross product is it's a way of analyzing vectors. But let me do this first. Would you put a big box around this formula? And what do you notice is different from the last formula you were at? So if you do A cross B, this is different than A dot B. What did we get when we did A dot B? We got magnitude of A, magnitude of B, what? Cosine. So this is different. And I'm not proving this, but I'm just showing you that this is the formula for cross product. And what it's saying is that the magnitude of A cross B is going to be the product of these times the sine of theta. And we're going to do a little math with this. Let's go I. What is the angle between I and I? 0. What's the sine of 0? 0, right? I should say the sine of theta. I should say the sine of 0 is 0. Okay. So what if we have I, and then we have this would be I, and this would be J. What's the angle between these two? 90. So theta is 90. What's the sine of 90? That's going to be 1. So when we look at this, I cross I, the angle is 0. So what's the cross product going to be? Well, each unit vector has a length of 1. So I has a length of 1. 1 times the sine of 0 is going to be 0. What will J dot J be? 0. What will K dot K be? 0. What will I dot I cross J be? Now, I cross J is going to have an angle of 90 in between. So it'll be 1 times the sine of 90. And what's the sine of 90? 1. So this is going to be 1. And this is going to be 1, and this is going to be, well, wait a minute, we got to be careful here. Yeah, there'll be 1, I'm going to say plus or minus. So now here's where it gets kind of weird. You're not used to this in math, but we're going to use our hands to determine a direction. Everybody hold your right hand up. How many lefties are there? Lefties are good people, but in this case, we're going to ignore you like usual. And I'm left-handed too. We're going to go with right-handies, and right-handers are going to demonstrate what I cross J is. So here's direction I, this way to the right. Here's J, up, and out. If you can imagine, this is out. This is going to be K, out of the bore. So we're going to do I cross J. So hold your fingers, go in the direction I, and then turn them in direction J. Where do you see my thumb pointing? Out. And by the way, is that K maybe? Is it positive or negative if it's out? Positive. So we're going to switch this 1, and we're going to call it vector K. That's what I cross J is. Okay. Is that the same as J cross I? Is it? J cross I, what happens? It points in. So this is going to be a negative K. So apparently here, this is different. Let's do I, and then K is out. So you start here, I, and then you move out. Where's the direction of J, up or down? Down. And how about K? Move it in direction I. What's the direction? This is negative. This will be positive. You try J cross K and K cross J. Just try those real quick. K is up. K is out. So J cross K is going to be I. And then what is K cross j going to be? Negative I. Well, wouldn't it be nice if you didn't have to do that? That's annoying, don't you think? That's annoying. So we actually have a method for calculating these. And before we go any further, let me just make this distinction right now. When we're talking about the cross product is an actual vector. Remember how I said the dot product didn't give you anything? I mean, it's a number. It helps you find an angle. But this is an actual vector. It is the vector that's perpendicular to both of these vectors. Super powerful. Just like the I cross j and the j cross k makes this vector, all of these things that we're going to do is going to make a vector, and I'm going to show you how to make that vector. It's very cool. We're going to use something called the determinant to figure it out. The determinant is, for a 3 by 3, is a rather complicated one. We're going to show you the determinant of a 2 by 2 first. This is going to be X marks the spot, like that. A times D, then B times C. And I don't have the derivation for this offhand, but it is a minus in between. So you're going to go AD minus BC. That's a 2 by 2. But this is a 3 by 3. And the way we're going to handle that is we're going to mix a bunch of 2 by 2s in it. So I'll hold on to this. Ooh, I didn't want that X. It's okay. We'll get rid of the X. There we go. All right. So we're going to do this 3 by 3, and we're going to do a determinant of it. And so would you put parentheses I, parentheses J, then parentheses K. And then this is my method. I don't know if it's the best method, but students like it. We're going to figure this out, we're going to cover this up. When we're doing the I, we're going to cover up what's underneath the I, and we're going to leave under J and K this nice 2 by 2. And with this nice 2 by 2, we're going to be able to do what we did here. A2, A2, B3, sorry it isn't R2D2, minus A3, B2, or B2, A3. I want the A first. So A3, B2. Okay, now I'm going to cover up. Let's go way to the end, to the K. We're going to do this last one. We're going to cover this one up. Now we reveal this 2 by 2. And that one's just going to be A1, B2 minus A2, B1. A2, B1. Ran out of a little room there. This is going to be plus this. Now, here's the exception to the rule. It's the one in the middle. Wouldn't it be great if we could do an X for this? But these aren't together, are they? What really is happening is this A1 is here, the B1 is here, and we're going this minus that. Okay, that's what's really happening. Okay, but what we're going to do is we're lazy, efficient, and we're going to make this X here. So because we're kind of cheating this should be over here. This is going to have the effect of making this minus. So then it's just going to be A1, B3 minus A3, B1. And that is the answer for A cross B. That's going to be the answer. It's going to give us an actual vector. I know, not super interesting, but it's very powerful. So let's do this. Is anybody still copying that? Let's do this one with an example, and I'm going to give you a little test practice. I want you to construct column vector A, B, A, C. So AB, Blake, can you tell me what AB is going to be? Head minus tail. So if it's AB, which is the head, A or B? B. So that's going to be 2 minus 1. And then what? Yep. And good. AC, how about Lauren? Tell me what you got for AC. -2, yep. Yep. 5 minus 1. So we have 3 points out in space, A, B, C. And then what you did just now is you went AB a vector, AC a vector. What we're going to be looking for is this vector that's coming out perpendicular to B, AB, and perpendicular to AC. That's the vector that we're finding. That's what A cross B is. So let's do it. Are you ready? This is going to be great. I, J, K. And then we're going to go 1, 2, 3, -2, -1, and 4. So I put this one in a row, then I put this one in a row. What do you think is going to happen if I switch these? What if I put 2, -1, 4 on the top and 1, 2, 3 on the bottom? What are you going to be finding? That one. Whoop. This one. You'd be finding that one, which we don't want. Okay? So the way I like to do it is I like to put my parentheses I minus parentheses J plus parentheses K. And then if you don't mind, I'm going to take the time to make my little rectangle that covers these up. And we're ready. 2 times 4 is 8 minus a -3. What's 8 minus a -3? 11, right? Then we move this one to the middle, and we just go 1 times 4, which is 4 minus a -6. And that's going to give me minus how many J? Yep, -10J. Thank you. And then the last one, we just go -1 minus -4. -1 minus a -4, which will actually be 3. This guy here is the vector that's perpendicular to both. We're going to call it the normal vector. Huge. And that vector is going to be used a whole bunch of different ways. If we did the other way around, it'd be -11, 10, -3. It would just be pointed downward. Okay. Ready for something easy? Real super easy. 2 quick applications here. Remember I told you that if you took the magnitude of the cross product, in other words, the answer, and then you found the magnitude of it, it would be the same as the magnitude of A times the magnitude of B times the sine of the angle. Do you like it when math comes together a little bit? Let's say I wanted to find the area of a parallelogram. Well, the area of a parallelogram is the base times the height. Because if you chopped this off and moved it over here, you could see that this is just, or excuse me, you chop this off, moved it into that gap, what do you have? A rectangle. So it's just base times height. So that's good. Now, we can find the area of this in a kind of a neat way is if you knew the magnitude of A, we want to find the area of the parallelogram. That's what we want to find. Well, I'm going to take this, and to find the height, what's the sine of theta? If this is b, and this is the height, what's the sine of theta? Opposite over what? Hypotenuse. Isn't that just h over the magnitude of b? Right? So wouldn't h be magnitude of b times the sine of theta? Or in other words, b sine of theta. Have you seen this magnitude of a b sine theta before? Yeah, it's the magnitude of the cross product. So no kidding. All you have to do is find the cross product, find the magnitude, and you got the area of the parallelogram. I don't like parallelograms that much. I like triangles better. Well, that's just going to be magnitude of the cross product divided by 2. Right? So that's kind of cool. Think that's good. Let's go right to the assigned problems. I like this number 2. It's great. So is 5, but I want to go to number 2, please. 2 and 3. Find a vector that's perpendicular to both 1, 2, 1 and 4, 6, negative 2. I want you to find the cross product of those. Go.